Welcome back to a lecture series on hydrogeology. So in this lecture, what now we are going to discuss about the graphical interpretation of water quality studies. Uh, After analyzing the water quality in terms of cations, anions, and minor elements, we will be getting the numbers. But by looking the numbers, normally we do analyze with 10 samples, maybe minimum 50 to 100 samples. But by looking the number, we could not be able to interpret the samples, or we cannot group the samples to categorize the samples into various uses like domestic, agriculture, and industry. And for this purpose, many scientists have evolved the diagrams like United States graphical diagram to interpret very quickly, because all graphical representation is better than the numerical representation. This is what all scientists believe and understand, that how that this graphical interpretation is going to help you for assessing the water quality and its uses. So in this line, so the US salinity laboratory diagram, this is also called the USSL. So this word is given here, USSL, and this diagram will be very helpful for interpreting the water for its uses for the irrigation. And this is the diagram, United States salinity lab diagram. It was developed by them. Yes, the scientist who has developed this diagram is Richard. He developed in the year 1950, and still this diagram being used by many hydrogeologists and hydrogeochemists, very specifically for interpreting the water samples into various uses. And it is widely used for the purpose of irrigation, not for the other uses like domestic and industry, because requirement with respect to various uses like drinking is different, other domestic uses are different, irrigations are different, and many industry like paper industry is different, and the leather industry is different. Like industry based requirement is also different. And this diagram is developed for the purpose of irrigation by using sodium absorption ratio. So excuse me. In this diagram, the sodium absorption ratio is plotted against specific electric conductance. So sodium, this is a salinity hazard diagram. Sodium is taken in y-axis and the EC is taken in x-axis. So this is how the samples are being taken with respect to both axes. In this diagram, SOR is plotted against sodium absorption ratio, or sodium hazard is plotted against electrical conductivity. So the diagram is divided into 16 areas. So EC is, so this is logarithmic plot. In this logarithmic plot, x-axis is by giving 0, 250, 750 to 2250 micromole per centimeter at 25 degree centigrade temperature, 2250 and above 2250. And similarly, the scale on y-axis is 0 to 30. So 0 to 10 is the first class, 10 to 18 is the second class, 18 to 26 is the third class. So this is the class interval of sodium alkali hazard. Sodium alkali hazard is classified on 4 scales on y-axis, and EC is taken as 4 scales in the x-axis. And the vertical lines are drawn parallel to the first line, and there are 4 columns here, and similarly 4 rows based on the value of sodium hazard is taken. Actually this interval from 10 to 18 is the cross interval, and similarly for 12 to 26 is the third one, and 4 to 10 is the first one. So you just now count, we will be getting 16 blocks. When you construct this x and y, we will be getting C1. This is the first one. Conductivity is being represented by C1, C2, C3, C4. C1 is low conductivity, C2 is medium conductivity, and C3 is high conductivity, and C4 is very high conductivity. Similarly, for S1 is representing low sodium hazard, S2 is medium sodium hazard, and S3 is high, and S4 is very high. And once if you get the samples, after analyzing the electrical conductivity and sodium hazard, sodium percent, then you will have to plot your samples over here. And you see this diagram is divided into 16 areas. The first area is C1S1, the second area is C2S1, the third area is C3S1, the fourth area is C4S1. Similarly, the second rows C1S2, C2, this area is C2S2, and this area is C3S2, and this area is C4S2. And here this block, it is C1S3, and this block C2S3, and this block C3S3, and this block C4S3. And similarly this block C1S4, and this block C2S4, and this block C3S4, and this block C4S4. And C4S4, now you will have to say, suppose if your sample falls here, low conductivity and low sodium hazard. Suppose if your sample falls here, high conductivity and high sodium hazard. Suppose if my sample falls here, medium conductivity and high sodium hazard. Like that, you will have to see the bottom rows representing the conductivity level, and similarly on the left side of the sodium hazard is being represented the sodium hazard level. So you will have to relate this, and then you will have to find out where your sample. Suppose you see here, cluster of sample falls in higher conductivity, low sodium hazard, and few samples falls in medium conductivity and low sodium hazard. This is how we will interpret by plotting our water quality analyzed data into this diagram, which are used to rate the degree to which particular water may give rise to salinity problems. Salinity problems here, salinity problems, and undesirable ion exchange and undesirable ion exchange effect. And this diagram is classified for the purpose of assessing irrigation uses. Conductivity is classified as follows: C1, C2, C3, C4. Conductivity of low salinity water, it is good for irrigation use. Medium salinity water, good for soils of medium permeability. Medium to high salinity, this is how I said. Medium to high salinity water, satisfactory for plants having moderate salt tolerance, and high salinity water, satisfactory for salt tolerant crop. So this is how, based on the conductivity, it is being classified, and the ranks are given for the assessment of water. Similarly, for sodium classification, this is sodium is classified into 4 classes. S1 is low sodium water, and it is good for the irrigation purpose. S2 is the medium sodium hazard water, which is good for coarse grained sediments. S3 is high sodium water, which is suitable only with good drainage. Suppose if you have a good drainage system is there in that particular area, so that what will happen, automatically the quantity increases and sodium will be reduced. I mean, if the concentration increases, and because of the dilution characteristics, the level of sodium will be decreased if the quantity is more. So very high sodium water, then we'll have to suggest it is not good for the purpose of irrigation. High sodium water can be made suitable for irrigation by adding calcium. Suppose if you add calcium by natural methods, automatically the sodium percent will decrease, and then you also can add gypsum, calcium sulfate, to saline soil. So this helps to increase, I mean, the possibilities of irrigation and its growth. So this is normally being practiced in some of the areas to improve the quality of water if it is high salinity. So with this, the discussion of United States Salinity Laboratory Diagram and its uses graphical interpretation is come to an end. Thank you very much.